In this video, we're going to actually cover two sections. We're going to go ahead and tackle 7.6, where we're going to be solving inequalities using addition and subtraction, and 7.7, where we solve inequalities using multiplication and division. And you're going to find this is very much like when we were solving our algebraic equations. So it should be a good jump from there. For example 1 in 7.6, we're going to be solving an inequality using addition, and they've asked us to solve x minus 3 is greater than 1, and then they want us to graph the solution. So the first thing we're going to do is we're going to set this up just like we do our equations, and of course the only difference between this with the two expressions is that they're not completely equal to each other because they have this greater than sign. But during the solving, we can kind of just put that out of our brains and we solve the way we normally do using inverse operations. So what we would normally do in our algebra to undo minus 3 would be to add 3, and of course whatever we do to one side we're going to do to the other. So these cancel each other out just like they did with our algebraic equations, and they leave us with just x on this side. So we've got x over here, and then on the other side we've got 1 plus 3, which is still 4, and then the only difference is instead of sticking that equal sign in like we have before, we're going to actually use the inequality symbol that we started off with, which is this greater than sign. And so we just solved our inequality once we got the variable isolated all by itself, and so it says our solution is x has to be greater than 4. Just like we did in 7.5, because they're asking us to graph the solution, we're going to put a number line down, and in the middle we're going to put whatever the solution is we know has to show up on that number line. So we're going to put 4 in the middle here, and we're going to go out at least a couple of spots in either direction. We were picking 3, you can go a few more if you want, but don't go less than that, please. And then you can do the same thing on this side, and you just count again in equal intervals. So make sure that you are counting in equal intervals. And then we have those same two questions that we have to ask ourselves that we did in 7.5. So we have to ask ourselves, what kind of circle? Will it be open circle or closed circle? And then we have to decide if it's going to have a line going to the right or to the left. And so to determine if it's open circle or closed circle, we look at the sign. It says x has to be greater than 4. It doesn't say it could be equal to. So we're going to leave that circle open because 4 is not a possible solution, but everything greater than 4 is, and that helps us answer our next question. Should we go to the right or the left with our line? So if x has to be greater than 4, it means it could be 5, 6, it could be anything to the right. It just won't be 4, and it can't be anything to the left. So you're going to make again a good sized line from this 4 out to the right, and that's graphing your solution. On this last on your own, there's a kind of an important hint I wanted to share, that because most of our other inequalities have had the variable on the left side, we're going to remember that just like in equations, sometimes the variable is going to show up on the right. So when we solve this, our solution ends up being 11 is greater than or equal to x. And if you stop and think about that for a second, that means that the x has to be less than 11, or it could be 11, if 11 has to be bigger than this. So sometimes another way to say that is to just flip the whole inequality around and to say that this is the same thing as x is less than or equal to 11. It might be easier for you to graph, it might not. You just have to make sure you're stopping and thinking about what could the variable be. It could be 11 because it could be equal to it, but it could also be anything less than 11. So when you set up your number line, make sure you keep that in mind. So your number line should look like this when you graph it, meaning that x could be 11, but it could also be 10, 9, 8, anything that is less than 11. For example 2, we're going to be solving inequalities using subtraction, and again, just like algebra, if we start out with with addition, then we're going to have to use that inverse operation of subtraction to undo the addition to isolate or get that variable by itself. So in 15 is greater than or equal to 6 plus x, the way we're going to get rid of that 6 plus x is to subtract, and we know if we subtract by 6 on one side, we're going to have to subtract by 6 on the other side of the inequality too. And just like before, those 6's are going to cancel each other out because it was an addition and a subtraction on the same side, and that's going to leave us with just x over here. And then 15 minus 6, of course, is 9, so that hasn't changed. And then, again, instead of putting the equal sign in there, we're going to put the inequality sign, and this one was a greater than or equal to. And just like on our last on your own problem, you can leave it as 9 is greater than or equal to x, and that just tells us that x has to be less than 9 because 9 has to be bigger than this. Or if it helps you to flip it around, you could also say that is x is less than or equal to 9. And either way, you're going to go ahead and graph it. So set up something where 9 is in the center. 10, 11, 12 works. And 8, whoops, that one's a little close. 8, 7, 6. And then same two questions as before. What kind of circle and which direction should the line go in? So if it could be less than or equal to 9, then we know that we're going to have a closed circle because 9 is a possible solution. And then if 9 is as big as it can get, then we know that we're going to be taking our line to the left, so that x could be 8, 7, 6, anything in this direction, but it can either be 9 or, but that's the most it could be. So there's graphing your solution. So now that you're getting the hang of these inequalities and solving, we're going to go right into 7.7 because this section has us using multiplication and division. We're going to start out using multiplication, so they ask us to solve x divided by 5 is less than or equal to 2. And again, because it starts as division, we're going to have to use that inverse operation of multiplication to undo that divided by 5. And I know some of you are still comfortable stretching that out to write it as x divided by 5 the long way. If that's working for you, I'm not going to stop you right now. But the other thing we can do in this case is just to remember that we multiply by 5 and that divide by 5, multiply by 5 cancels each other out. And then if we multiply by 5 on one side, then we've got to multiply by 5 on the other. And so over on the left side, that leaves us with just x. And on the right side, that leaves us with 10. And then we keep that inequality sign the same. So now our solution is x is less than or equal to 10. And we graph exactly like we did in the last couple of examples. So once we have our solution, we're going to ask if we're going to do open circle or closed circle. And if x is going to be less than or equal to 10, we're going to put in a closed circle because it means 10 could be a solution. But x could also be anything less than that. So it could go 9, 8, 7, anything in this direction. So you make your line going to the left. And that's graphing x divided by 5 is less than or equal to 2. And for our last example in this video, we're going to use division to solve the inequality. So again, inverse operations tells us that we must have started with multiplication then if we're going to undo it using division. So if our original inequality says 4 times n is greater than 32, then we know that we undo multiplication by dividing by 4. And then if we divide by 4 on one side, then we have to divide by 4 on the other side. And these two 4's cancel each other out because 4 divided by 4 leaves us with just 1n on the left side. And then 32 divided by 4, of course, is 8. So we've got the greater than symbol here. And so our solution is n is greater than 8. And now we're going to graph that. So if n is going to be greater than 8, we're going to put a circle on 8, and it doesn't say that it could be equal to, so 8 isn't a possible solution in this case, which means we're going to leave an open circle, but it then says n could be greater than 8. So that means it could be 9, 10, 11, anything to the right. So our line is heading to the right for this graph. And since this is the last example that we're going to go through, there are a couple of real-life application examples that we'll talk about in class, but we're going to just call it quits after this example, but you might notice that I only gave you one set of on-your-own problems this time. We're going to do a few more on-your-owns in class as warm-ups and together just to make sure you're understanding it. But if you could handle the first set, then it should just be like solving equations, and then the graphing piece is just like we did in 7.5. So hopefully you're catching on, and we'll be practicing it some more together in class.